Okay, so today we'll probably encounter probably the most difficult. I'm not even sure if most difficult is the right word. The equations that require the most number of steps to solve. Okay, and what they're going to look like is we have brackets and fractions. Right? So before we get going, a reminder of what we did in the past to help refresh our memories. We had questions like this. 3x plus 8 equals 10, and we needed to solve. We split it at the equals. We needed to move two numbers to the other side, a 3 and an 8. Which number did we move first?
8.
How did it look like on the other side?
Minus 8.
-8. You took your number that you had to add or subtract, you wrote it on the other side as its opposite. It's positive 8 here, becomes a -8 on the other side. Right? And we have a 3x equals 10 minus 8, which is a 2. Then what did we do? Divide by 3 to get rid of the 3. 3 times x, so opposite of time thing is dividing, and those 3's disappeared, and x is equal to 2 over 3. Okay, then we made the another level of difficulty increase is why we threw in some brackets. And I gave you questions like this. Right? And what I said is, hey, let's get rid of these brackets by taking the number outside the brackets and multiplying it through the brackets. So we took this 2, we multiplied to the x. What did we write down? 2x. Then we took that 2 and we multiplied to the next term. What did we write down? Positive or negative? -8. And we still had that 10 sitting there. Okay, so now it became like a question like above. What number do we move over first? The 2 or the 8? The 8. How does it show up on the other side? Positive 8. Then we need to get rid of that 2. We divide by 2. Okay? So now we're adding one more step in. Okay? And this step is the same as we did in the past whenever we had fractions inside of our equations. And was, hey, we're going to get rid of the fractions by making everything integers. Right? So in this chapter, we got rid of the fractions by making everything integers. How did we do that? Does anyone remember what we did a couple of weeks ago? How did we get rid of fractions? Right? We multiplied by something. Do you guys remember what we multiplied by? No? Blank stares? Common denominator. Right? So we got rid of all the fractions by multiplying everything by the common denominator. So here, in the denominator, we have a 2 and we have a 4 sitting here. What is our common denominator? Emma? 4. So what we do is we multiply every fraction, every term, by 4. So we take the first one, I'm going to multiply this by 4. I'm going to take the second one over here, I'm going to multiply that by 4. Just like we did last time. Okay? Except for it looks a little bit more complicated now. So now, what we do is we compare the bottom number to the number we multiplied and try to get rid of that denominator. So we go, how many times does 2 fit into 4? Right? How many times is that? Twice. Thank you. So we crossed out the 2, crossed out the 4, and you put a little 2 above there, just like we did last time. Right? So now what we have left behind is 2 times the top here. So we're going to write that down. 2 times the top in brackets. Right? Because the 2 multiplies everything on the top. Right? And over here, how many times does 4 fit into 4? Once. Right? So we cross out the 4, cross out the 4, and we were left with a 3 times a 1, which is just a 3. Okay? So now this becomes a question like we did last day. Okay? We need to get rid of the brackets by taking this 2 from outside the bracket and multiplying it through. So what do we write down for the first multiplication? Emma?
2x.
Thank you, Emma. Then we take this 2 and you multiply it to the next term in the brackets. What do we write down? -2. 2 times -1 is -2. And we still have this 3 on the other side of the equals. Okay, now we go and we attempt to solve. Okay, and so we look on the side of the variable, the x. We got a black 2 and a green 2 sitting there. Which 2 do we move over first? The black one or the green one?
Green.
Green, right? The one we have to add or subtract. How does that 2 look like on the other side? Emma?
Positive 2.
Yeah, thank you. So we take this 2, we move it to the other side. We've done plus 2 here because it's the opposite, and we cross this one out. So now we clean this up. We have a 2x sitting here, and we have a 3 plus 2, which is just 5. Now what do we do with this 2 sitting here? Divide by 2, just like we did before. It's 2 times x. The opposite of timesing is dividing. So let's just switch colors here. Divide by 2. Divide by 2. The 2's are gone. X is 5 over 2. And we are done. Okay? So we've added an extra step in. Right? So you see fractions? Step 1, get rid of fractions. All right? Use the common denominator. Common denominator. That's the process we use. Step 2. We now have brackets sitting there. Right? Get rid of brackets. Right? And step 3, we solve. Right? Get rid of fractions, get rid of brackets, solve. Right? Okay, let's do another one over here.
Almost done, right?
Oh, you're okay. I'll give you a couple more seconds here. Yeah. Now, the tricky thing with these fractions is the same question can be written slightly different and looks completely different, right? And that's what we have on the right-hand side here. Is we got another fraction question here, but it looks completely different because of the way the numbers are represented here. So this thing off to the side, this x minus 8, that's really in the numerator, right? So I'm going to rewrite this to make it look like what we have here, because this is a little bit nicer way to see things. Right? So I take this 3 and take this x minus 8, because they're both in the numerator here. Then I'm going to take this and I'm going to put this over 4, the denominator. So it all looks like one nice big fraction. Right? And we're going to clean up the right-hand side as well. Now, all the way throughout this course, we give a mixed number, we want to convert it. So if you come across a mixed number, we convert it to an improper fraction. What would the improper fraction here be?
15.
Yeah, 15. Right? We multiply, then add. 2 times 7 is 14. Add the 1, gives us a 15. And the bottom number stays the same. Okay. So now, we do exactly what we did before. We look at the denominators. Right? So step 1, get rid of these fractions. We have a 4 and a 2 sitting there. What's our common denominator?
12.
12, sure. Right? 4 would work, 8 would work, 12 would work. Right? All those would work. But Chase said 12, so we're going with 12. So we're going to multiply this by 12, and you can multiply this by 12. Okay? So now we're working on still step 1, get rid of fraction. Right? We figured out our common denominator. Now we get rid of our denominators. 4 fits into 12 how many times? 3. So we cross out that 4, we cross out the 12, we're left with a 3. Now this is where students make a mistake. Right? So this 3 only multiplies one thing in the numerator. It doesn't do everything. So we go 3 times 3. We're left with a 9. And the stuff in the brackets. Okay? Now the other side. How many times does 2 fit into 12? Not 11 times. Riley?
7.
Not 7 times either.
6.
6. So we're left with 15 times 6, which is 90. Okay. So now the fractions are gone. We go to the next part, get rid of the brackets. All right, so we have this 9 outside the brackets. We take it and multiply it through the bracket. So what is the first term that we write down for this purple arrow? 9x. And for the blue arrow, what do we write down for this multiplication? Not negative 8. Nope. We got to do 9 times negative 8. Negative 72 equals 90. Okay? So now the brackets are gone. We go to solving. Right? So we look on the side of the variable, we got a 9, we got a 72 sitting there. Which one do we move over first?
72.
How does it look like on the other side?
Plus 72.
Plus 72. We get rid of this 72, we write down the opposite on the other side. So we have a 9x sitting here, and 90 plus 72 would be 162. All right? Then we need to get rid of that 9. How do we get rid of that 9? Divide by 9. Divide by 9. X is equal to 162 divided by 9, which should be a nice whole number, I think.
18.
18. Thank you. All right. How is that? Is it doable? Like it's a lot of steps, right? But keep the goal in mind. Okay, would you want to do another one? No? Not. Anybody else? Right? I just heard one person.
Let's try it.
Let's try it. Or how about I give a slightly different question? Let's take this and I'm going to say let's erase this and let's put just a 5 there. Let's erase that and just put a 5 there. Okay? How does that change things? All right? Our first step is still the same. All right? We want to get rid of the fraction. So what is our common denominator? What are our denominators? Right? We have a 2 here, and there's nothing over there. Or if you want, you can put an imaginary 1 in. So what is our common denominator? 2. Okay? So now we're going to multiply both sides by 2. So this has multiple things in the numerator. So we go 2 times the top, and we put that in brackets. So it really highlights the fact that we're going to multiply everything on the top by 2. Okay. And we multiply the other side by 2. So now we clean up. Okay. 2 fits into 2 how many times? Once. So I cross out this 2, I cross out this 2, put a 1 there. All right? And so we're left with a 1 times x minus 14. Right? And the other side, well, 1 fits into 2 times, so that doesn't change anything. So you're left with a 5 times 2, which is just a 10. Okay. Now, if you want, you can do your arrows through here, but 1 times anything doesn't change that number, right? 1 times 3 is still 3, 1 times 156 is still 156. So this, when we multiply through the brackets, still is going to stay exactly the same. On the other side, we've got a 10 sitting there. Okay. Now, what do we do? Right? We need to solve. We're not done until the point where x is all by itself. So we only have one number on the same side of the x. How do we get that 14? Do we add it, subtract it, multiply it, or divide? Add it. It's negative 14 on this side, positive 14 on the other side. So we add 14 here. So x equals 10 plus 14, which is 24. Okay? I think you guys got this. This is good. I think I want to give you more time for your assignment. We will only do one word problem. And they're both similar. The top one involves the square. The bottom one involves the triangle. Last time we did questions with triangles, so let's do a question with a square this time. Okay? So I'm going to avoid setting up equations as much as possible. All right? And sort of use logic for the most part, because I think that's what you guys need to work on first, is just understanding the problem. Okay, so here it says we have a square with a perimeter of 49.2. So I'm going to draw myself a square. And remember, a square has all sides the same. And it says perimeter is 49.2. And the word perimeter means the distance all the way around. So the distance all the way around is 49.2 centimeters. Okay? And it says the length of the square is represented by this formula here. So length, so a side is x plus 4.1. And the question is asking us, how big is x? Okay? So what we really need to do is figure out how big are the sides. Then we can figure out how big is x. Right? There's multi-steps here. So if all the way around event is 49.2,
Yeah.
how big is one side? How do we figure that out?
You divide it by 4.
Yeah, so we take that 49.2 and we divide it by 4 because all the sides are the same size. Right? So we take that 49.2 divided by 4. I'm going to grab my calculator for that one. 49.2 divided by 4, and I get 12.3. Okay? So now we can say that this is 12.3 in size. Okay? So we know this is 12.3 in length. It's also x plus 4.1. So these two things are equal. Right? They're the same size. Right? We just need to figure out what the value of x needs to be, so this whole thing equals 12.3. So this is where we set up a little mini equation. So we go x plus 4.1 equals 12.3. Right? They're the same value. That's setting up your equation. So now we need to find the value of x. So we have a little equation. That 4.1's got to go. Do we divide it? Do we multiply it? Add it? Subtract it? Subtract. It's positive 4.1 here. We subtract 4.1. Right? The opposite on the other side. So x is equals 12.3 minus 4.1. So 12.3 minus 4.1. I think that's 8.2. 8.2. So with a word problem, we give a little statement. The value of x is 8.2, and it says the units here we're working in centimeters, so it's just 8.2 centimeters. And the triangle question is very similar. Okay, so I'm going to leave it at that and use the rest of the time